For question 3.01 and 3.02, we're asked to calculate moles that we have and atoms in a sample based on how many moles we have. So for the first one, how many moles of oxygen atoms are there in 5.0 e to the negative 1 moles of CO2? So first we want to convert this into non-scientific notation. So we have 0.50 moles of CO2. Now it's asking how many moles of oxygen atoms are there within that sample. So what we need to do is break the sample down to see that in carbon dioxide I have 1 carbon and I have 2 oxygens. So this calculation would look like I've got 0.50 moles of CO2, and I know for every 1 mole of CO2 I have 2 moles of oxygen. We see that up here when we break apart carbon dioxide. For every 1 mole of carbon dioxide, I would get 1 mole of carbon, 2 moles of oxygen. So moles of carbon dioxide cancel out. 0.5 times 2 would give us 1 mole of oxygen atoms. And in scientific notation, 1.0 e to the 0 mole of oxygen atoms. The next calculation is a little bit more involved. How many atoms of fluorine are there in 1.0 e to the 0 moles of carbon tetrafluoride? So for this calculation, I know moles of carbon tetrafluoride. I've got 1 mole of carbon tetrafluoride. We're not asked for moles of fluorine, we're asked for atoms of fluorine. So to break this down, I have 1 mole of carbon tetrafluoride, and I know that in 1 mole of carbon tetrafluoride, do the same thing we did before. From the carbon tetrafluoride, I break that down into 1 carbon and 4 fluorines. So that means 1 mole of carbon tetrafluoride would have 1 mole of carbon and 4 times as much fluorine. So 4 moles of fluorine. Moles of carbon tetrachloride, that cancels out. So I have 4 moles of fluorine. But we're asked for how many atoms of fluorine we have. So the last step in this calculation, I've got 4 moles of fluorine. I need to multiply by something that allows me to convert from moles of fluorine into atoms of fluorine. And that's Avogadro's number, right? For every 1 mole of fluorine, I would need to have 6.02 e to the 23 atoms of fluorine. So 4 times 6.02 e to the 23 would give me 2.4 e to the 24 atoms of fluorine. So just pay attention and be careful what you're asked for. If you're asked for moles, right, or if we're asked for atoms or molecules, that'll be the sign of what you have to calculate. If you're asked for atoms or molecules, then a light bulb should go off in your head thinking, I'm going to need Avogadro's number to help me relate moles to atoms or molecules. If you're asked to find moles, then we just need the mole ratio, or we need, if we're going from grams to moles, right, the molecular or the atomic weight